Hello, students. Mr. Murphy here, and we skipped lesson 6, and that totally made me forget we're taking a test. So let's review for a test. I'm going to give you some what we're talking about, give you some examples, and then I'm going to give you a couple of problems on this, and then you're going to work on them, and we'll work on them in class. All right. So first of all, what is an exponent? So an exponent is any number with a base and a power, right? So the exponent, oh, come on. Exponents would be like 5 to the power of 4, right? So we've got a base to a power, and what does it mean? It means multiply 5 times itself 4 times. So the power tells us how many times we multiply the number by itself, and the base is what we're multiplying, okay? What are the rules of exponents? I'll get to those in a second. Prime factors is something I didn't really talk about a lot. So prime factors is like if I have a number like 8, and this is a popular one, the prime factors is, well, I can factor it. 2 times 4 is 8. 2 is a prime number, but 4 is not a prime number, so 4 can be factored as 2 times 2. So the prime factorization for 8 is 2 times 2 times 2, and I can use that as an exponent by saying 2 to the third power, right? So 8 can be written in exponential form. It's 2 to the third power. And then like 16 can be written in exponential form as 2 to the fourth power, because 2 times 2 times 2 times 2, well, this, we know this is 8 times 2 is 16. And 32 and 64, etc. All right. So you did prime factorization in like 4th and 5th grade when they were talking about fractions and stuff, but it comes important here too. So let's say if I have a number 6 times 10 divided by 3, I can factor all of these, and that helps me to reduce the fraction. So 6 is in prime factorization 2 times 3. 10 in prime factorization is 2 times 5. And 3 is already prime factored. So now, if I want to reduce this, I can cancel these out, and 6 times 10 was 2 times 3 times 2 times 5, and then the 2 times 2 times 5 is 20. 2 times 2 is 4, 4 times 5 is 20. So if I was going to factor, if I was going to multiply this out and then divide by 3, I would still get 20. All right, so that's prime factorization. Now, if we are doing with exponents, it's really done the same way. Let's say if I had 6 to the 8th times 10 to the 3rd over, let's make it bigger, 27 to the 4th, right? So 6 to the 8th is 2 times 3 to the 8th power. And then 10 is 2 times 5 to the 3rd power. And then the prime factorization of 27 is 3 times 3 times 3. So that's 3 to the 3rd to the 4th power, right? So we've got a couple of these laws of exponents in here. If I have two numbers being multiplied and they're raised to the same power, then each one can be raised to the same power. So 2 times 3 to the 8th power is 2 to the 8th power times 3 to the 8th power. And then 2 times 5 to the 3rd power would be 2 to the 3rd power times 5 to the 3rd power. And then 3 to the 3rd times the 4th would be 3 to the 3rd, 3 to the 3 times 4, because when you raise a power to a power, you multiply. So 3 times 4 is 12, so that will be 3 to the 12th power. Okay. So let's combine all of our stuff. I've got 8 2's here, and I've got 2 to the 8th here and 2 to the 3rd here, so I can multiply those together. 2 to the 8th times 2 to the 3rd times 3 to the 8th times 5 squared over 3 to the 12th, right? So 2 to the 8th times 2/3 is 2 to the 11th. 3 to the 8th divided by 3 to the 12th. Notice I can divide any of these by 3. They're all being divided by 3 to the 12th, but I'm just going to concentrate on these. So 3 to the 8th divided by 3 to the 12th is 8 minus 12 is 4. So that would be -4. It's going to be down here. So 3 to the 4th. And then 5 squared has nothing, so 5 squared. So 6 to the 8th times 10 to the 3rd times 27 to the 4th reduces to 2 to the 11th times 5 squared divided by 3 to the 4th. Okay, does it make sense to you? If I multiply all those out, I would not be able to reduce that fraction that I end up with. All right, and I'm going to go over rules of exponents, then I'm going to give you some problems to work on your own in our Go formative. Okay, so the rules of exponents. Our first rule of exponents is if I have two exponents with the same base being multiplied, then I add the powers. If I have a exponent raised to a power, then I'm going to multiply the powers. Two numbers being raised to a power, raise each number individually. That's two numbers being multiplied, not added. X to the first power is x. X to the 0 power is 1. So any number to the first power is that number. Any number to the 0 power is always 1. And then if I'm dividing, that's very much the same as multiplying, except I'm going to subtract. And this says I cannot be dividing by 0, right? So those are your rules. Write those down. You can use them in your test and then practice the problems that I give you. And this is a bonus problem. So any digit 1 to 20, you use that most 1 times each, fill the boxes to create an equivalent expression. So this is equal to this, is equal to this, is equal to this. Okay? All right. Good luck. We will work on the practice problems together in class, but I want you to get started on them on your own.